All right. Today, our learning goal, I can identify the point where two lines intersect. Let's talk about what that word intersect means, okay? Well, when we have equations, they form a line on a graph, and we've already seen that because we have looked at that line. So let's say this is one equation, and let's say this is another equation. All right. The intersection is where they cross. So it's the point at where they cross. And remember that your point, the x is always first, and then the y. All right, so that's what we're going to be doing today. So let's get our notes and get started. A math teacher instructed students to graph the following equations on a coordinate plane. If graphed correctly, at what point will the two lines intersect on the coordinate plane? All right, well, we need to do a couple of things. First off, we're going to be using our calculator. And I need y'all to go, and I hope you have your binders because you're going to need your binders today. And the first thing we do is always set our windows. Okay, when we're putting in equations in our calculator, we are going to set our windows. I'm not going to show you how I'm doing that because we have been over this many times. But what I am going to do is remind you that either on the back of your orange or yellow reference chart, which should be in the front of your binder under RC reference charts, okay, you have the steps, all right? So the first thing you always need to do is to set your windows. So I would like you to pause this video and set your windows. Okay, hopefully you have done that now, okay? And next, also on the back of that orange or yellow reference chart, is how to solve algebraic equations. And when we used y equals. Now, in the past, we've had two equations, and they've been on opposite sides of the equal sign. We still have two equations here. So in other words, in the past, you saw them written like this. Plus 2 is equal to 2x plus 4. Okay? That is the same thing as this. Okay? So just because they have y equals this and y equals this doesn't mean any difference than if they had this and this. And remember how we took care of this? We put 1 under what? y1, and the other under y2. So we're going to go to our y equals, and under y1, we are going to put 2.5, and remember x is next to the alpha key. You don't use the x's all in here, plus 2. We're going to then under y, we're going to go down to y2, and we're going to put in 2x plus 4. Okay? So if graphed correctly, at what point will the two lines intersect on the coordinate plane? Now, in the past, what they've asked is what is the value of x that satisfies both of these equations, essentially. Okay? Well, now we need a point, and we're going to handle it the exact same way. We're going to hit graph, and we're going to wait for that to come up, the two lines, just like we did before. Okay, then we're going to follow the same steps. Second, trace 5, because remember we want the intersection, which is 5, and it says first curve, enter, second curve, enter, guess, enter. Now before we were only concerned with the x value. Now we need a point, which is an x and a y. So we've got it here. At 412, these two equations, their lines intersect. So our answer is 412, which is D. Now another way we possibly could see these is here. A student graphed two linear equations and saw that the lines intersected at 4.75. So here's your x value, here's your y value on the coordinate plane. Which pair of equations did the student graph? All right, the easiest way to handle this is just to go and eliminate, all right? So I'm going to go back to y equals. I'm going to clear both of the equations that I have put in there already. And I'm going to go up to y1, and I'm just going to start. 4x plus 4, and I'm going to go to y2, and I'm going to put in 2x plus 3, and I'm going to hit graph. And I know this takes a little bit of time, but remember, on a test, you're only going to have one question that might be like this, so it's not really that big of a deal. Second, trace, 5, enter, 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 and I find that this one, they cross at negative 0.52, which is not the pair that I'm looking for, so it can't be A, okay? Oh, we have a fraction. What do we do with fractions? Well, some of you use alpha F1, which is fine, okay? You can do that, but if you don't, you need to use parentheses. So here I go. I'm going to go to y equals, I'm going to clear, I'm going to clear, I'm going to go back up to y1, and it doesn't matter which one you put in y1, which one you put in y2, okay? Parentheses, x divided by 2, parentheses, plus 0.5, and I'm going to put in exactly what I see and make sure it's correct. I'm going to go down to y2, and I'm going to put in 2x subtract 1.25. I'm going to hit graph. Remember, I'm looking for the point 3, 4.75. I'm going to hit second, trace, 5, enter, enter, enter. And I'm still, this is not 3, 4.75, so I could mark off B. Go back to y equals, hit clear and hit clear. Go back up to y1. I've got another fraction, so I'm going to put it in parentheses for me. Some of you will use alpha F1. X divided by 4. Close my parentheses, plus 4. Then I've got 2x subtract 1.25, and I'm going to hit graph. Remember, the point we're looking for is 3 and 4.75. And now I'm going to do second, trace, 5, enter, enter, enter. And guess what? 3, 4.75. So I've found my answer. Okay? All right. This is the most common way. And unfortunately, then, this means that you have to be able to read your x and y value. Remember that your x-axis is going horizontally. So in order to find, and remember that the x comes first, then the y. So I need to fill this in. I'm trying to find what this point is. Okay? What ordered pair best represents the intersection of the line segments ON and MP? Okay? All they want to know is where do they cross? Okay? So I'm going to start at my origin. And since I'm going left, it means I'm going to have a negative x, doesn't it? So I've got negative 2, okay, on the x. Now this is y, so then I'm going to go up to my y, 1, 2. So negative 2, 2. And here's my answer, B, negative 2, 2. Okay? You got to be careful, though. You always have to go left or right, then up or down, because x is always left or right, and your y value is up or down. All right, here's another one. If the two linear equations, y equals 3x subtract 7 and y equals negative 2x plus 3, are graphed on the same coordinate grid, which of the following is the solution to both of the linear equations? Now, I'm looking at this, and since I know it's where they intersect, if I was going to guess, they intersect right here, and I would go, start at the origin, go right 2, and then down 1. So 2, down 1. Now, I know some of you are going to say, okay, well, that has to be it. You know what? I'm going to check it just to make sure, because sometimes it's hard to tell, or sometimes we're not sure. So I'm going to go back up here, and I'm going to put in 3x subtract 7, and then I'm going to put in negative 2x plus 3. The problem is you need to make sure that your equations that you put in are exactly what you see. Remember that when it's in the middle, it's a minus sign. When it's out front, it's a subtract sign. I'm going to graph it. I'm sorry, a negative sign, not a subtract sign. Please don't listen to that. Second trace 5, enter, 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 and it tells me I'm at 2, -1. So C would have been my answer. Okay? All right, that's all I have for notes today. I do want you to know in your packet there are 15 questions, but it should go pretty quick. I would like you to do me a favor, and I want you to come to the back and start with the spirals. Okay?